Right. We are in, day 263. Okay. So I missed 2 days in between, 2 to 3 days in between. I made on 17 and 18 now, May. Now this is, I will see 2 to 3 videos in the one day. So this is uh, 263 day countdown to create 2027. Okay. What we will learn in this particular class today, we will see the heat transfer area or heat exchangers, in which this is known as, as you can see, this is known as something heat exchanger effectiveness. So what should I write? So this is heat exchanger effectiveness. Okay, let me actually take this out so that it will be clear for you also. Heat exchanger effectiveness. So this is the concept in the subject heat transfer. Okay, as you can see, the symbol is given as heat exchanger effectiveness. This is the symbol is given, and you can say Q, heat exchange actual by heat exchange max. But we need to understand, we need to define these two. This is known as uh, actual heat transfer. All right, this is known as actual heat transfer. This is maximum possible heat transfer. Maximum possible heat transfer. Now, in such conditions of how do you see, if I just look at this particular ratio, this is effectiveness is not something. No, I'm saying this is a variable and this is numerator and something called denominator. This is in this form, right? When do we say this particular variable will increase? Will increase definitely when this is, it's a vice versa, right? So in such conditions, let us understand a little more of what is this heat transfer effectiveness and all. So heat transfer effectiveness, and we have two quantities here. This is numerator and denominator. Now, what is this numerator? Numerator is Q actual by this is Q max, right? So this Q actual heat transfer is nothing but we can write in terms of the either hot fluid or the cold fluid. So how do we write? See, generally if I say this is if I write with respect to the hot fluid, MH and CP of MH. So this is known as into TH1 minus TH2. So what does it mean? Hot fluid temperature inlet will be more than the outlet, right? So definitely this is written like this. This also can be written as MC, CPC, and TC2 minus TC1. I think you know why we are writing like this, right? Now this again, now we have something called denominator, which is known as Q max, is given with respect to the two inlet flow rates. So if I write CH, what does this CH mean? CH means nothing but this product. CH is nothing but this product. What does this product say? Hot fluid capacity rate into TH1 minus TC1. See, that is the maximum possible heat transfer what we can actually achieve. And we can also write this in terms of the cold fluid. And let me change the color here. Yeah. You can also write this in terms of, uh, if I write CC, but this remains same, you can see what is happening. So now CC is what? Cold fluid, hot, sorry, cold fluid capacity rate. So this is again, you can say, let me change the color here. Now this particular value, MC into CPC, is into the cold fluid capacity rate. That is known as CC. So definitely this is Q max means minimum of these two values. If you take this and this, if you have two values you have calculated, and in those two values, minimum of these two values can be taken as our Q max. So that's way our what you call heat transfer, heat exchange effectiveness is calculated.